Hi, everyone. I'm happy that you're here today. I hope you are enjoying our Liferay Developer Conference. I am André de Oliveira. I am Search Engineering Lead in Liferay, and today we are going to talk about intelligent information discovery, machine-driven search. In the massively digital world where we live today, we have a problem. We have an explosion of content. Content coming from all sides, everywhere, to us, to our users. It is a massive cause of attention deficit. I can guarantee you that before the end of this talk, half of you will be looking at your laptops or smartphones, paying attention to something else. So that's the world we live in today, and can't be helped. At any given time, you are exposed to social media, email, notifications, music, pictures, your vehicle sending you traffic notifications, Google Now. It's so much content that you are coming to a point where you need to decide where you are going to apply your interest, and your users feel the same way. With so much content, there must be a way to give them what they want, quality content, before they even know they need it. They need an information discovery strategy that fits their interests. Once upon a time, this information discovery strategy in applications was based in browsing for content. So you had the main path for discovery for users in applications was the navigation menu. There's where users will go to find out what your application could offer, what content was available for them. So it was kind of a customer journey with a rainbow. You remember when websites had breadcrumbs where you would visit your content in a predictable, structured way, and with enough time, any user could visit and find out everything that your site had to offer. You could have a product catalog with all categories available for your users. And there was no sign of search. The best you could offer was filters with SQL queries. And it was primarily click, 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 click. And that's how your users discovered what was available for them. For many legacy applications, that's how it still works. But then we found search, and that's where we are right now. Most modern applications have a search bar for users to discover what is available, to navigate with freedom to whatever content is available for them. So you have now applications that use both databases and search engines. Search engines give you much more freedom with full text search, facets to group categories. It's still a matter of your users deciding what they want to find, so they need to attempt several different queries until they find what they want. It's trial and error. And whatever you have, content information indexed in your application, the results your users get are the users for that moment. Your results are in the now. Anything that's new, anything that comes in after your users finish their searches is lost from their attention span. So now we live in a world where you design your applications thinking of keywords for your users to find content that is available. And with the explosion of content I mentioned, we are heading to the next generation of information discovery strategy. There is where you predict what your users want to find. So there will be no more single discovery gateway for users. Information will be discovered and presented everywhere. You already see it in several leading search-centric websites, like you can visit the front page of Amazon and you will see several results already pre-searched and available for you based on your previous visits and your purchase history, even the content you already browsed before. Everything is used as an indication of interest. This is the dominant discovery strategy in applications in the near future. The information discovery for your users will be primarily driven by their indications of interest. Your application will drive search. Users will still search, but the application will pre-search and deliver content to your users before they knew they wanted it. This is what we call intelligent information discovery. And as everything, it started with search. It's not a coincidence that leading search engine, search technology companies are leading research in interest-based information discovery. With the field of information retrieval, with document searching, full text queries, it goes beyond the database in a sense that before information retrieval, you could get information from your database with simple filters. So it was something very Boolean. It was true or false, match or don't match. But with information retrieval, you get a shift in paradigm that you have mostly fuzzy results now. So based on full text queries and other factors, you can get scored results. Results that are likely to match what your users are searching for. It doesn't need to be exact. You have ranking algorithms, you have relevance algorithms to tell your users how likely it is that their results match what's relevant. So, how do you use a search engine available for you in our applications to predict what content will be relevant to display to your users next time they visit? As a matter of fact, there are several techniques that you can use with search engines right now to predict relevance to your users based on interest. We are going to see more about them in a few minutes. So, a few examples. You can autocomplete as your user type, several different strategies for autocompletion. You can match what your user types against document titles in your content base, or you can suggest popular queries that match what they are typing as they type. You can also correct what your users are typing with Did you mean against a spell check dictionary. On search results, you can use more like this to match all result documents against other documents in your content base to display similar results. And you can use sophisticated techniques like percolators to predict categories for incoming documents so they are already available to display for users that fit that category when they visit. So in this order, these are techniques that more and more take the burden away from your user to decide what they want to search and let your application decide by itself. The common denominator in all these techniques is you have an input of search keywords, and the output is scored predictions in order of relevance. As it comes, we are now discovering with machine learning a new world where you can use data science to predict results based in user input, and these results have scores, just like search. You can train neural networks now to make educated guesses, to make predictions. A scored guess will give you confidence that the matches, the results you have, match prior results that you told the neural network are the expected results. There are algorithms in machine learning that are universal. They are reusable. They are pure mathematical algorithms like regression, classification, clustering. But after you have a trained neural network, it behaves like an API. You can feed it any kind of data, any kind of document, any kind of input you have, as long as you can encode it in numerical form. The input for all these algorithms is numerical, but the output is always a scored prediction. For example, you can have as input for a neural network pictures or voice snippets or search queries or any indication of interest that your user gives you. If you can model it as meaningful numbers, your neural network will give you a scored prediction in the other end. Image classification encodes images based on color values to end up with a matrix of numbers. So from pictures to pixels to numbers, you get adequate input for your neural network. If you are working with speech recognition, the sound waves you have to work with can be expressed as a matrix of frequencies and amplitudes. So if you think of those sound wave heights as numbers, a sound wave can be expressed as a numerical matrix, and then it goes in the neural network you see to the right. So your brain is going to recognize what is in the sound snippet, and a neural network will be able to process numerical input in the same way to recognize speech. Face detection is yet another example of you taking a model from reality and encoding it in numerical values. The most basic face detection algorithms will work with landmarks that you choose in a face, and based on calculating the distance across these landmarks, these distances can be expressed as a numerical matrix, and this can be fed into a neural network to proceed with your facial detection algorithms. And that enables the neural network to, just like us, start seeing faces everywhere. So coming back to our neural network, you see, to the left, you have numbers coming in as input, your universe encoded, expressed as numbers. It goes through several layers of processing, applying algorithms with weights, feeding into themselves. And in the end, what you get is a document from your result universe with a score, with a prediction, how confident the neural network is that this document matches the input you give. If you want to know more about machine learning and how you can use machine learning solutions with DXP, I highly recommend that you attend the presentation in this Liferay DevCon, Machine Learning and DXP, the best of two worlds, from Carlos Hernandez and Felipe Afonso. Lots of very interesting stuff you can do with machine learning and DXP. So, you get scored predictions with machine learning, with confidence, and this is really similar to what you get from search engines with Similarity. This is Similarity is a ranking model, is a scoring model. So you can see in the results you get from the Elasticsearch Explain API on your queries. There are several numbers that correspond to Similarity, scored result for your prediction, and you can switch the algorithms that you use with the Elasticsearch Similarity module, so you can fine-tune what you are looking for. Some models suit different kinds of fields better, and BM25, divergence from randomness or independence, information-based. There are several ways for you to tune the algorithms to get best similarity. To transform your search in numbers that you can use as input, you need to go through textual analysis. So, in a very summarized way, what you get is your search engine will use primarily the term frequency, inverse document frequency, or TF-IDF algorithm to tokenize the text, create term vectors, like positions of your terms in text, prepare a matrix with how many times the term appears in the document, so you can see your words have weight amidst the entire universe of words in your entire index. So this is something that is really important to understand if you want best relevance in your search results. How often a term appears in a field, how rare the term is in the whole index, how short the field is. So a word in a field that is short may mean this field is a title. So all of these factors improve relevance in the position where the result will appear in the scored results in Similarity. If you want to understand the entire math, there are very informative articles in the Elasticsearch documentation, I recommend. And there are several steps you can take, just like in machine learning, you need to sanitize input several times before it's suitable for deep learning algorithms. In search, you will improve your predictions by sanitizing your input. So you may want to remove irrelevant words like articles and connectors from your input. Perform spell check before the search is executed. predict when your user is searching for serial numbers, so you will need to choose different analyzers depending on the kind of data, apply different analyzers to different fields. Predict that there's more than one way that your user can find one thing. You may need to search for several synonyms, split words versus searching for the entire word in a combined way, and contextualize, because depending on your application, certain search terms will have more meaning than usual, like a medical application. So you need to prepare, and if you search for something, you will always want to display a certain set of search results if one word appears, regardless of relevance. So all of this is pointing to a future where your application will drive search before your user takes the initiative. So your application will want to predict relatable searches based on a universe of searches that all other customers, all other users made before. So you will want to start indexing searches performed by your users and cluster them, classify them by interest group in order to suggest and push predictable, relatable results. One very simple way to start providing feedback to your users is with Autocomplete. So the base case of Autocomplete just suggests how to complete your search, be it based on document titles, be it based on popular queries, successful queries previously done. This base case is quickly exhausted. You will want to improve suggestions, your application performing pre-searches and displaying results in your search bar. You may want to combine several different kinds of queries. So instead of just performing a full text search with user input, you will want to match by phrase, by prefix, to give more priority to documents that have a title based on what the user is typing. You may want to match more fields, so you will display results that match not only by title, but also by content or description. And target multiple entities, like you may want to display in the drop list different kinds of entities like users, groups, wiki pages, journal articles, blog entries. With more like this, you have a chance to display under your result list a list of similar products or similar articles to the ones that your user found. So in this case, to use the more like these algorithms from search engines, TF-IDF, the relevance score, is key. The document you request will be analyzed, same as the fields you are targeting. TF-IDF will be calculated as a numerical value, and the top terms in the document will be recombined as an OR query that takes in consideration top terms only. So it's an efficient way to predict other results of interest for your user based solely on the search query. Up to this point, we are not yet predicting for interest. A more sophisticated way to find results, pre-find results that are interesting for your users is the percolate feature from search engines like Elasticsearch, where as soon as you have new content in your application, new articles, new products, you can pass this new content through predefined queries that are tied to categories, to classifications, so you effectively classify content as soon as it gets into your application, so that later when you have a user visiting, a user that you already determined that has categories matching the categories, you can pre-display content. If you want to learn more about Percolate, I recommend attending the talk, going in reverse to move forward, how reverse querying gives you fully automated publishing by Jan Verjage in this Liferay Developer Conference. And now it starts getting interesting because you are going to recommend results based on what your users are looking for. Here, the key is to store the previous successful searches. A successful search depends on what your customer journey is. So you may want to store searches that result in clicks or result in purchases. But as soon as you index successful searches, you can use them to match users who are performing the same customer journey. So you will group your users by customer profile and use this information to inform your search engine that for this category of users, you want to pre-search with previously indexed queries performed by other users in the same category. Here, I recommend that you attend the single customer view demystified presentation in this same Dev conference from Jonathan Lee to have more insight in how DXP is using data science and single customer view to group users by interest. And for smart content delivery, you have several options for how you want to let users know about what interests them. So before I had searched by how to clean your searches before executing them, Amazon thinks that I'm trying to scrub my searches. That's why it recommends this to me. So you can display your search results in your front page, in your search bar, or search results, as we discussed, in the content view itself, or through push notifications, as long as you can pre-search and present, and also anticipate possible content, possible products that may influence your users based on your conversion goals, and you can display alongside your results, and use your users' future indications of interest to improve your intelligent information discovery. I will use my last 1.5 minutes to give you a preview of what's coming next in Liferay Search for our next version. We are going to ship Liferay with Elasticsearch 6. There are several new features that should help you to predict and refine your information discovery. There are also interesting options for machine learning coming on in the next version. We are modularizing our search infrastructure. So for you that are familiar with implementing base indexers, you will have more options to implement small single-purpose components that you can mix and match together with composition instead of inheritance. It will be more reusable across several indexers and easier to test. With the new modularity in components, we will also have modularity in the user interface. So we are moving past the classic search portlet, and we will provide several portlets that you can mix and match in your search pages, so you can build one or several search pages according to your application. You will be able to combine search components in the same page as content, asset publisher, any other portlets you have to build a highly customized search experience for your customers. including multiple selection facets and map components, and your own search-aware portlets that you decide to write. The Liferay Commerce application that you may have already heard of uses extensively our new search technologies. So I recommend you attend this presentation, Liferay Commerce, a preview of our upcoming features from Marco Leo. And our vision for intelligent information discovery in the next versions of DXP is DXP interacting with all possible ways for you to predict what your user needs, be it search engine with classic prediction strategies, artificial intelligence as a service platforms, APIs that allow you to use image classification, speech recognition, face detection as services, or if you have a data science team and you want to use single customer view and other data-driven development technologies, you can build your own data-driven application infrastructure and host it on WeDeploy to do search classification, customer interest prediction, machine learning training models, recommendation engines, everything working together to provide you with the best intelligent information discovery. Thank you, and I hope you make many discoveries here in the Liferay DevCon conference. Thanks.